Hello everyone, I am Nikita Nayak from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In previous video lecture, we learnt about some important remarks and examples, and today we are going to learn another examples. Now example 1. Three men are shooting at a target. The probabilities that they hit the target are 0.5, 0.6 and 0.8 respectively. A. Find the probability that all three hit the target. B. Find the probability that all three miss the target. Here, three men are shooting at a target. We have also given the probability of hitting the target by three men. Now, A. We have to find the probability of all three men hit the target, and B. We have to find the probability that all miss the target. So, let A be the event that first man hits the target. Therefore, probability of A equal to 0.5. Let B be the event that second man hits the target. Therefore, probability of B equal to 0.6. And let C be the event that third man hits the target. Therefore, probability of C equal to 0.8. Now, probability that all three hits the target. Here we know that the event A, B and C are independent because they are not depend on each other. So, probability of all three hit the target equal to probability of A into probability of B into probability of C. And we have given probability of A equal to 0.5, probability of B equal to 0.6 and probability of C equal to 0.8. So, probability of all three hit the target equal to 0.5 into 0.6 into 0.8. And 0.5 into 0.6 into 0.8 equal to 0.24. So, probability that all three hit the target is equal to 0.24. Now, we have to find the probability that all three miss the target. That is, first man miss the target, second man also miss the target and third one also miss the target. So, now we have to find that probability of all three miss the target equal to 1 minus probability of A into 1 minus probability of B into 1 minus probability of C. So, 1 minus probability of A, and we have given probability of A equal to 0.5. So, 1 minus probability of A equal to 1 minus 0.5. 1 minus probability of B, we have probability of B equal to 0.6. So, 1 minus 0.6 and 1 minus probability of C, we have probability of C equal to 0.8. So, 1 minus 0.8. Now, 1 minus 0.5 equal to 0.5. 1 minus 0.6 equal to 0.4. 1 minus 0.8 is equal to 0.2. So, we get 0.5 into 0.4 into 0.2 and 0.5 into 0.4 into 0.2 equal to 0.04. So, probability of all three miss the target equal to 0.04. Now, example 2. If A and B are two possible outcomes of an experiment such that probability of A equal to 0.4, probability of A union B equal to 0.7 and probability of B equal to P. Find the value of P if A and B are mutually exclusive and A and B are independent. Here we have given that A and B are two possible outcomes of an experiment such that probability of A equal to 0.4, probability of A union B equal to 0.7 and probability of B equal to P. Give equation number 1. We have to find the value of P if A and B are mutually exclusive and A and B are independent event. So, number 1, given that A and B are mutually exclusive, we know the definition of mutually exclusive event. What is the mutually exclusive events? Two events are said to be mutually exclusive if occurrence of A prevents the occurrence of B and vice versa. That means occurrence of B prevents the occurrence of A. So, A intersection B equal to 5 implies probability of A intersection B equal to 0. Give equation number 2. Now by addition theorem of probability, we know that probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now we already have probability of A equal to 0.4, probability of A union B equal to 0.7 and probability of B equal to P. So probability of A union B equal to 0.7. Therefore 0.7 equal to probability of A, that is 0.4, probability of B, that is P, and by equation 2 probability of A intersection B equal to 0. So we have 0.7 equal to 0.4 plus P minus 0. Now P equal to 0.7 minus 0.4. So we get P equal to 0.3. So when A and B are mutually exclusive event, P equal to 0.3. Now second, we have given that A and B are independent. So what is the independent events? We know the definition of independent event. Two or more events are said to be independent if happening or non-happening of any one doesn't affect the happening or non-happening of any other. So, since A and B are independent, probability of A intersection B equal to probability of A into probability of B. But already we have probability of A equal to 0.4 and probability of B equal to P. So here we get probability of A intersection B equal to 0.4 into P. Give equation number 3. Now again by addition theorem of probability, we know that probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now by equation 1, we already have probability of A union B equal to 0.7, probability of A equal to 0.4 and probability of B equal to P. So here we get 0.7 equal to 0.4 plus P minus probability of A intersection B equal to 0.4 into P. So here we get 0.7 equal to 0.4 plus P minus 0.4 into P. Now 0.7 minus 0.4 equal to P minus 0.4 into P. But P is common. So here we get 1 minus 0.4 into P. Now 0.7 minus 0.4 equal to 0.3. 1 minus 0.4 equal to 0.6. So here we get 0.3 equal to 0.6 into P. Therefore, P equal to 0.3 over 0.6. So we get P equal to 0.5. So when A and B are independent events, P equal to 0.5. Now example 3. A problem in mathematics is given to 3 students A, B and C whose chances of Solving it are 1 by 2, 1 by 3 and 1 by 4 respectively. What is the probability that the problem will be solved? Here we have given that a problem in mathematics is given to three students A, B and C, and we have to find the probability that the problem will be solved. So here we have to find the probability that at least one student will solve the problem. So for finding the probability that A, B and C cannot solve the problem, first of all we have to find the probability that A, B and C cannot solve the problem respectively. Here we have given that the probability that A can solve the problem is 1 by 2. Therefore, the probability that A cannot solve the problem is 1 minus 1 by 2, because we know that P plus Q equal to 1, where P is the probability of success and Q is the probability of failure. So, probability of success plus probability of failure is equal to 1. So, probability of failure, that is Q, equal to 1 minus probability of success, that is P. So, Q equal to 1 minus P. So, here we have the probability that A cannot solve the problem is 1 minus 1 by 2. Now, we have also given the probability that B can solve the problem is 1 by 3. So, the probability that B cannot solve the problem is 1 minus 1 by 3. Also, we have given the probability that C can solve the problem is 1 by 4. So, the probability that C cannot solve the problem is 1 minus 1 by 4. Now, the probability that A, B and C cannot solve the problem equal to 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 4, because here events are independent. So, 1 minus 1 by 2 equal to 1 by 2, 1 minus 1 by 3 equal to 2 by 3, 1 minus 1 by 4 equal to 3 by 4. Now here 2 cancel out and 3 cancel out. So we get 1 by 4. Therefore, the probability that A, B and C cannot solve the problem equal to 1 by 4. Now, the probability that the problem will be solved, that is, the probability that at least one student will solve the problem. At least one, that is, one or more than one. So, equal to 1 minus the probability that A, B and C cannot solve the problem, that is 1 by 4. So, here we get 1 minus 1 by 4, and 1 minus 1 by 4 equal to 3 by 4. So, the probability that the problem will be solved is 3 by 4. In next video lecture, we will learn about total probability and Bayes theorem. Thank you.